Greetings to all. I welcome you all to this video lecture. In this video lecture, let's discuss on the topic eye pattern. So in the previous topics, we discussed about the ISI, inter-symbol interference, and we also discussed about the Nyquist criteria for the symbol to be free from ISI. Okay, so we all know that the quality of a digital transmission system is determined by the bit error rate. For example, if you are transmitting the data in the communication system from the source to the receiver, we pass the data through a channel, right? So there's high probability that this the noise may get added, or we can say there are other possibilities. The quality of the signal may get degraded during this process of modulation and the transmission and reception. And we also discussed the one possibility is inter-symbol interference. The adjacent symbol get interfered with the nearby symbols, right? So eye pattern is one experimental method that is used to measure the information concerning the degradation of quality. We'll talk in detail later. So just to measure the effect of the ISI inter signal, we can use this eye pattern, right? Or we can say that when we view the received signal through oscilloscope, it may appear to be in a pattern of eye. Let's discuss in detail. So we know that when we receive the signal from the source to destination, there are possibilities that our signal may get prone to inter-symbol interference, right? So eye pattern is a pattern displayed on screen of cathode ray oscilloscope. It's a pattern that we see on a cathode ray oscilloscope. The shape of the pattern resembles of a human eye, therefore we call it eye pattern. So whenever we see the received signal displayed on a screen of a CRO, the shape resembles to be that of a human eye. That's why we call it an eye pattern. The eye pattern is a practical way to study the inter-symbol interference and its effect on PCM and data communication system. So this is by seeing the pattern of the eye, by seeing the CRO which appears to have the pattern as that of the eye, we will be able to study the effect of inter-symbol interference in the signal. Now let's see this diagram. Imagine that we have input bit 1 0 1 1 0. The first bit 1 is transmitted, then we are transmitting 0, again 1 1 and 0 1. What you see here is in the receiver side during reception, the signal, we may not have the perfect reception of signal. If we just take this each time instant, and place it over the another, take the first time instant and take the second time instant, third, and place it one over another and see the help of CRO, you may get an visualization in this pattern, which may looks to be a pattern of eye. With this, we will be able to study the effect of the inter-symbol interference in the signal. So the eye pattern is obtained on the CRO by applying the received signal to the vertical deflection plates of the CRO and the sawtooth wave at the transmission symbol rate. So in this way, we will be able to get this pattern. This pattern, this pattern, you can see this eye opening here, is redrawn, for a better understanding. We are just redrawing this pattern for a better understanding. And imagine, let's consider this diagram. So this is called eye opening, and this is how it looks. This is how it looks. So what we can infer from here? That's more important. Let's see what we can infer. The first thing is the width of the eye. This is the other time interval over which the eye can be summoned. This we call as the width. So the width of the eye opening defines a time interval over which the received signal can be sampled. So this width defines the time interval over which the wave can be sample. Okay. The second point is sensitivity is determined by the rate at which the eyelid close. Okay. So what we understand is, like, when the effect of ISA is excessive, okay, what happens is, imagine when there is too much of ISA. When there is too much of ISA, what happens is, you could infer that this eye opening, this slowly closes. This region becomes zero. That is, the eye opening, the margin of noise, we'll discuss as the next point. This becomes zero. Okay, when there is too much of ISA, okay, the trace from the upper portion of this eye pattern, okay, crosses with the lower portion. They meets up so that the eye will get closed. At this point, we say we won't be able to retrace the signal. So the next observation is the height of eye opening. Okay, this is eye opening. The height of eye opening. Okay, the height of eye opening defines the margin over the noise. So when the effect of ISA is severe, okay, the ISA is completely closed and it is impossible to avoid error due to the combined presence of ISA and noise system. So when the effect of ISA is severe, okay, the eyelid is completely closed and it's impossible to avoid error, or it is impossible to reconstruct the transmitted data because of the combined presence of ISA and the noise in the receiver. This is one of the major important point. Okay, so these are the inference that we can get from this eye. So this eye pattern gives an insightful information about the characteristics of data transmission system. Okay, if the data transmission system is effective, okay, it's effective, and the possibility of ISA is less, and we may have a perfect reception where the eye opening will be quite large. So this eye pattern acts as a visual indicator to tell how well or how poorly the data transmission system performs, okay, while transmission of data in the physical channel. Okay, so it gives some very insightful information and visual information to say how well the data transmission system is performing, okay, over the channel. Thank you. Thanks for watching this video.